Hello, today I am taking topic viscosity. Viscosity is a property that represents the internal resistance of fluid or in motion, and it is also called fluidity. If a fluid is in motion, maybe gas or maybe liquid, the layer of the fluids will have some frictional force between them, and that frictional force produce an internal resistance, and that internal resistance is called viscosity. And second point is drag force. If an object is moving inside the liquid or gas, the object will get a drag force. Here is a kite moving in air. The air has some layers, and the kite is moving opposite to them. Then it will get a drag force. Similarly, in case of water, we may assume some layers. The object is face. It is moving opposite to the motion of the water. Then the drag force will affect the motion of the body of face. A fluid moving relative to a body exerts a drag force on the body because of friction caused by viscosity. So to find out the viscous force, we use the Newton's law. It is an important law. Here we are taking the liquid surfaces. The liquid layers are there, and the bottommost layer, AB, is a solid layer. The topmost layer has the motion. This wants to accelerate the velocity of the lower layer, whereas the lower layer will reduce the velocity because of the friction between the layers. So the velocity is decreasing downward in vertical direction. The velocity is decreasing as we are moving downward. Here the layer of liquid is Mn and Pq. The upper layer is Mn, which having velocity v plus dv, and the lower layer is v. The upper layer has more velocity than the lower layer. The difference between the distance is dx, and the dragging and the viscous force is opposite to the direction of motion of the liquid layers. The viscous forces depend on the area of the layers, either of Mn or of Pq, and also depend on velocity gradient. The viscous force is proportional to velocity gradient. It means it is dv by dx, difference of velocity upon distance between them. If we combine these two equations, we will have equation F is equal to eta A dv by dx. Eta is coefficient of viscosity. A is area of layer, and dv by dx is velocity gradient. So viscous force is equal to eta. Eta is proportionality constant. This proportionality constant is called coefficient of viscosity. Now we able to define the coefficient of viscosity. If we take the velocity gradient as unit between the two layers and area of the layer is also unit, then eta will be equal to F, that is viscous force. So tangential force, that is viscous force, required to maintain a unit velocity gradient between the two layers of each unit area is called coefficient of viscosity. Or the coefficient of viscosity is defined as viscous force acting per unit area between two layers moving with unit velocity gradient. If we plug the dimensions of force, area, velocity, distance, then we are able to find out the dimension of eta as well. And the dimension of coefficient of viscosity is m1, L minus 1, T minus 1. Next point of interest is Stokes' law. If object falls vertically downward inside the fluid, here the liquid column, the fluid is there in form of liquid and the object is falling down. Here we are taking three objects of different size. What happens? Whenever the object is falling down, the viscous force comes there and this viscous force opposes the downward motion. As the velocity increases because of the gravity, this viscous force also increases. And at a time, the viscous force will be equal to the weight of the object, then the net force on the object became zero. The retarding force increases with increase of the velocity of body. So consequently, the resultant force acting on the ball became zero. If force is zero, the acceleration will be zero. And when acceleration is zero, the velocity will be constant. And this constant velocity is also known as terminal velocity. The constant velocity achieved by the object which is falling is called terminal velocity. So according to Stokes' law, the viscous force is directly depend on coefficient of viscosity, radius of object, and terminal velocity. And whenever you may use the dimensional formula, F depend on eta, F depend on R, F depend on V, then you will able to find the formula F is equal to 6 pi eta R Vt, as we already find in the class. And this equation is Stokes' equation and law is Stokes' law. Now next point of interest is we have to find the terminal velocity, that is the constant velocity when object is falling down. Let us say here is an object and because the object is falling down vertically downward inside the liquid because of its weight. The initial velocity will increases because of the acceleration due to gravity. But same time, the viscous force also increases and in opposite direction. One another force will also act on this object, that is buoyancy force. The force of buoyancy. It is represented here by U. This comes because of the object is replacing the liquid here, and the displaced liquid will produce a buoyant force opposite to the direction of motion. This buoyant force also acts on a ship which float on the surface of sea, because fish ship replace some liquid, and this replaced liquid will produce buoyant force. So here buoyant force acting on the object is also upward, and after some time the total upward force will be equal to the downward force, that is the weight. Now we have to find out the value of force of buoyancy. It is equal to the weight of the liquid displaced, that is mass of the liquid displaced into g, and mass, you know, density of liquid into volume. If density of liquid is sigma, displaced volume is v, then the u is equal to sigma vg, and the weight of the solid is mass of the solid sphere into g. So density of the solid sphere into volume, so it is rho vg. V of solid object is equal to displaced liquid, and same time the viscous force is acting upward. It is 6 pi eta rvt. Now we will plug the value of buoyant force and the viscous force and the weight on equation 1. Then sigma Vg, that is buoyant force, plus 6 pi eta rvt will be equal to weight of the object, that is rho Vg. So 6 pi eta rvt is equal to rho Vg minus sigma Vg. We may take common Vg. So 6 pi eta rvt is equal to Vg into rho minus sigma. V is volume of object. Let us consider it is a sphere, a spherical object. Then we may write the volume as 4 by 3 pi r cube. That is volume of a sphere. Then we are able to find out the terminal velocity. Vt is equal to 2 r square rho minus sigma g upon 9 eta. Pi will cancelled. So the terminal velocity is depending on square of the radius of object, difference of the densities of solid and liquid, and inversely proportional to the coefficient of viscosity. If rho is more, Vt will be positive. If rho is less than sigma, it will be negative, as in case of air bubble. For air bubble, air has lesser density than the water, then air bubble will move upward. The terminal velocity became negative. So the terminal velocity is depending on a square of radius, difference of densities, and inversely proportional to eta. This equation is important equation to derive for terminal velocity. Now let us consider the liquid is moving in horizontal direction. The velocity of liquid layer is maximum in center of the tube, because we know at the ends the velocity decreases toward the ends. The velocity decreases toward the ends. If we apply a pressure on the liquid in one side of the tube, then the liquid will come out. The rate of flow of liquid means volumes coming per unit time. This volume of liquid comes out from the tube per second is proportional to fourth power of radius applied pressure and inversely proportional to coefficient of viscosity and length of the tube. Student, you may able to find out this equation by using dimensional analysis. But the variable will be the rate of liquid is depending on radius, rate of liquid depending on coefficient of viscosity, and third is rate of liquid depending on P by L, that is pressure per unit length. Then you will able to find this equation by dimensional analysis as well. Right? Thank you.